Okay, hello. Sorry, I'm Olivia. Welcome to another pre-AMC 8 video for the San Antonio Math Include YouTube series. Let's get started. We've got a 3-digit integer contains one of each of the digits 1, 3, and 5. What is the probability that the integer is divisible by 5? Alright, so what would it take for the number to be divisible by 5? We've got a couple combinations that we can see. So we've got 1, 3, 5, 1, 5, 3, 3, 1, 5, 3, 5, 1, 5, 1, 3, and 5, 3, 1. Those are our 6 combinations that we could have. Okay, so which of these would be divisible by 5? Okay, well, something important to know. It's okay if you don't already know. That's why we learn. Is a 5-digit number, or a multiple of 5, is going to end in either 5 or 0. Right? We can see that playing out when we list our multiples of 5. We got 5, 10, 15, 20, right? The multiples of 5, they end in 5 or they end in 0. So which of these 6 combinations ends in 5 or ends in 0? We got 135 and 315. The other 4 end in either 3 or 1. So the probability that an integer with those 3 digits is divisible by 5 is 2, right? Because there's 2 of them out of a total of 6 combinations, right? And we can simplify that. 2 out of 6 is the same as 1 over 3, right? You can divide 2 by 2 and 6 by 2 to get 1 over 3. We've got Austin and Temple are 50 miles apart along Interstate 35. Bonnie drove Austin to her daughter's house in Temple, averaging 60 miles per hour, leaving the car with her daughter. Okay, this is a little complicated, so let's draw this out. So Austin, here we'll have Austin and Temple. They're 50 miles apart. All right, 50 miles. Bonnie drove from Austin to her daughter's house in Temple, averaging 60 miles per hour. From Austin to Temple. Okay? Leaving the car with her daughter, Bonnie rode a bus back to Austin along the same route and averaged 40 miles per hour. So she drove back. Here she drove there 60 miles per hour and back 40 miles per hour. What was the average speed of her round trip in miles per hour? All right, let's see. So if she's driving the 50 miles at 60 miles per hour, how long is it going to take her? So 50 miles, 60 miles per hour. So how long, if you're going at 60 miles per hour, that's 1 mile per minute, right? Because there's 60 minutes in an hour, we've got 1 mile every 1 minute. So to drive there, it would take 50 minutes, right? 50 miles in 50 minutes. Just like 60 miles in 60 minutes. So that's 50 minutes there. All right, what about on the way back? Well, 40 miles per hour. We want to go 50 miles. So in 1 hour, she'll have gone 40 miles. So that's 60 minutes. Plus, right, after an hour, she still has 10 more miles to go. How long will it take you to go 10 miles if you're doing 40 miles per hour? 10 miles at 40 miles per hour? Well, you can do 1/4 of an hour, right? Because 10 times 4 would be 40. So it'd take 1/4 of an hour, 1/4 of the time. So 1/4 of an hour, that's 15 minutes. So 50 minutes from Austin to Temple, and then 60 plus 15, that's 75 minutes back. So what's the average? That'd be 50 plus 75, 125 divided by 2. All right, no, 50, okay, sorry. It'd be 50 times 60 miles per hour, so 50 minutes. 50 minutes, that's 5/6 of an hour, times 60 miles per hour, plus 75, right, that's 1 1/4, so 5/4 times 40 miles per hour, right, and we can simplify that. 5 times 10, 5 times 10, okay, so 50 minutes and 75 minutes. And so that means it took a total of 50 plus 75. That's 125 minutes to drive 100 miles, right? 50 miles to Temple and then another 50 back to Austin. So 125 minutes to drive 100 miles. Okay? So how many miles were driven in a minute? That'd be 100 divided by 125. We can simplify to 4/5. So 4/5 of a mile per minute. And we have 60 minutes an hour, so we'll multiply this by 60. Simplify that to 4 times 12, that's 48. Average speed is 48 miles per hour. Answer choice B. Okay, the recipe that makes 5 servings of hot chocolate requires 2 squares of chocolate, 1/4 cup of sugar, 1 cup water, 4 cups milk. Okay. If she maintains the same ratio of ingredients, what is the greatest number of servings of hot chocolate she can make? So we need 5 hot chocolates, 5 servings of hot chocolate, 2 squares of chocolate, 1/4 cup of sugar, 1 cup water, and 4 cups milk. Okay, Jordan has 5 squares of chocolate, 2 cups of sugar, lots of water, so we'll just say infinity, and 7 cups of milk. Okay, so we see that she can make a lot, right? So what's going to be her limit? Could she make 2 times this recipe? Well, 2 times the amount of chocolate she could do. 2 times the number of sugar she could do, right? 1/4 times 2 is possible. 2 times the amount of water she could do, but she can't do 2 times the amount of milk, right? That's not going to be possible. She's limited with the amount of milk. So, we know for sure she can make 1 times the recipe. That's 5 servings. And after she makes 1 time the recipe, now we have 3 cups of chocolate, 1 3/4 of sugar, still have infinity water, and 3 cups of milk. Okay, so we have 3 cups of milk, and we need 4 cups of milk, so we can only do 3/4 of the rest of the recipe, right? 3/4 of that. So, right, because 3/4 would use 3 cups of milk. So if we have 3/4 of 5 that we can make, what's 3/4 of 5? That's 15/4. Right, so we can do another 15/4 servings, which is a little less than 4, right? So 5 plus 15/4, that's 3 3/4. 5 plus 3 3/4, that's 8 3/4 servings of hot chocolate. All right. How many 3-digit positive integers have digits whose product equals 24? All right, so we want the product to be 24 of the digits of a 3-digit positive integers. So how could we make 24? Well, we know 24, that could be 1 times 1 times 24. Well, no, that doesn't work. We need only single digit numbers, right? So we know that 8 times 3 makes 24, 6 times 4 makes 24, 12 times 2 makes 24, and that's what we're going to work with, right? So 8 times 3, we could break that down by saying 8, 3, and 1. We could break down the 8 and say 4 times 2 times 3. That's how we could break up 8, 3, and 1, right? Keeping 8 or turning it into 4 and 2. Okay. What about 6 and 4? Well, we could have 6 and 4 and 1. Or we could break down the 6 and have 2 times 3 times 4. Or we could break down the 4 and have 6 times 2 times 2. Okay? And then lastly, we have the 12 and the 2. We have to break down the 12 And by breaking down the 12, we have to do 6 and 2 or 3 and 4. We already have 3 times 4 times 2, and we already have 6 times 2 times 2, so the 12 would only repeat values. So we could have any combination of 8, 3, and 1, 4, 2, and 3, 6, 4, and 1, 2, 3, and 4. Oh, we've double counted. This is why we go over things. 4, 2, and 3, and 2, 3, and 4, that double counts, so we cross one of them out. And then 6, 2, and 2. Okay, how many combinations could we make like this? With 8, 3, and 1, there's 6 ways to do it, right? 8, 3, 1, 8, 1, 3, 3, 1, 8, 3, 8, 1, 1, 8, 3, 1, 3, 8. So that's 6 ways to do that. There's also going to be 6 ways to do this one, right? 6 ways to do this one as well. This is a double count. All right, 6 ways, 6 ways. So that's 18 ways. Plus our 6, 2, and 2. Now this one's a little different, right? Because we can only do 6, 2, 2, 2, 6, 2, or 2, 2, 6, right? There's only 3 ways because there are 2 2s, right? So that's 18 plus another 3. That makes 21 ways to do that. We've got positive integers x and y are the two smallest positive integers, and the product for which the product of 360 and x is a square, and the product of 360 and y is a cube. What is the sum of x and y? All right, so if we want to find squares and cubes, we're going to need to find the factors of 360, right? And remember, a square is a number that's like a times a, where a is a number, that number is a square. And a cube, again, that'd be like a times a times a. So the same factor 3 times. So what are our factors of 360? Well, we could divide it by 3. 360 is 3 times 120, right? We can't split up the 3 anymore. What about 120? We can divide that by 3. That makes 40. 40 is 4 times 10. And we can split up 4 into 2 times 2, and 10 into 2 times 5. Okay. So multiplying 3 times 3 times 2 times 2 times 2 times 5, so all of the circled numbers, that gives us 360. And because we split it up like this gives us the opportunity to write out the prime factorization of 360, right? So it's 2 times 2 times 2 times 3 times 3 times 5. We can write that as 2 to the third, right? Because there's 3 2's. 3 squared, because there's 2 3's, times 5. Okay, now in order for this number to be a square, all of the powers need to be even, right? So we need, instead of 2 cubed, we need the next biggest. We need 2 to the fourth. We can keep 3 squared, right? That's already even. And we'd need 5 squared, right? That's what we need for it to be a perfect square, right? All even powers. Okay, so what are we missing? Well, we have 2 cubed, and we need another 2, right? To be 2 to the fourth. So we're missing a 2, and we're also missing a 5, right? We have 5, we want 5 squares. 5 squared, so we need a 5. So that means x is 10, right? 2 times 5 is 10. That's x. Okay, for y, we need to go from, we have 2 cubed squared times 5. We need powers of 3, right? So 2 to the third can stay 2 to the third. 3 squared, we need 3 cubed. And 5, we need 5 cubed. Okay, those are all powers of 3. So what are we missing? We already have 3 2's. Now we need 3 3's. So we need another 3. And we need 2 more 5's, right? We have 1 5 and we want 3 5's. So we need 2 more 5's. So y would be 3 times 5 times 5. And that's 25 times 3, that's 75. Y is 75. Okay, so now we have x and y, and we want to find their sum. So we want to add those two together. What's x plus y? 10 plus 75, that makes 85. Answer choice B. Okay. The diagram represents a 7-foot by 7-foot floor that is tiled with 1 square foot black tiles and white tiles. The corners have white tiles. If a 15-foot by 15-foot floor is to be tiled in the same manner, how many white tiles will be needed? Okay, right now we have 7-foot by 7-foot, but we'd want 15-foot by 15-foot. Okay, the corners are always white. That's something that we already know. So I'm going to draw out, maybe not drawing out a 15 by 15, but we'd have white in the corners and then black everywhere else. So next would be black next to those corners. So we want to know how many white tiles are needed. Let's count out our first row. So in our first row, we'll have white and black. So we start out with a white, then we go black, and then we keep alternating. White, black, on and on, until we get to 15. So now we're at 15. We've got 8 white and 7 black. Okay, so that seems like we've got a good start. But then remember, in our next row, it's going to be all black, right? Here's our white, black. Now it's an all black row. So this will have 15 blacks. So every other row, we're going to need 8 white tiles. But then in the rows between those, we'll just have 15 black tiles. So how many rows are going to have white tiles in them? The first row is, and the 15th row is. The second row won't, and the 14th row won't. So it'll be all of the odd rows will have white tiles. That's 1, 3, 5, all the way to 15. How many odd tiles are there? How many odd rows are there? 1, 3, 5, 7, 9, 11, 13, 15. That's 8 odd rows. 8 rows that have 8 white squares. 8 times 8, that's 64 total white tiles. Now we have 2 angles of an isosceles triangle, measure 70 degrees and x degrees. What is the sum of the 3 possible values of x? So for an isosceles triangle, 2 angles are going to be the same, and one of them is going to be different, right? So either we have 2 70 degree angles or 2 x degree angles. So let's check that out. So let's say that we have 2 70 degree angles, right? We have a 70, and an x. So in that case, what would x be? Okay, well, the angles of a triangle always add up to 180 degrees, right? And right now, we only have 2 70 degree angles. So 70 plus 70 is 140 degrees in our triangle. And we need 180. And that's where x comes in, right? We have 2 70 degrees. We need x degrees to add that up to 180. So 140 plus what equals 180? That would be 140 plus 40 would make 180. So x in that case is 40. So our first case is x is 40. Okay, what's next? Well, we could have 2 x degree angles, right? So in that case, we've got 170 and 2 x's. So in that case, what's x? Well, remember, a triangle always adds up to 180, and we have 70 degrees accounted for, so we're missing 110 degrees. And those 110 degrees are going to be taken up by 2 x's. So 2 times x is 110. Okay, we can solve for x by dividing by 2. X equals 110 divided by 2, that's 55 degrees. So in that case, x is 55. Okay, now we have one last case. That's where x equals 70, right? So that's 2 70 degree angles, in which case that's both x. And we already discussed that before. In that case, the third angle is 40. So we have 70, and then x, which is also 70, and then a 40 degree angle. So that's our third case where x equals 70. Okay, adding that up, 40 plus 55 plus 70, we get 165. Answer choice D. How many non-congruent triangles have vertices at 3 of the 8 points in the array shown below? Let's take a look. So let's draw this out. We could either do, I'm going to end up drawing a lot of triangles. That's okay. We can start with a triangle that looks like this. So we can go in a corner, or we could go one more in a corner like that, or we could do even more in a corner like that, right? So that's 3 different ones, right? One, more. Okay. Another way we could do it is we go like this, or we could go like this, right? So that's 2 more slantways and then a slightly more slantways. Okay. Another kind is if we went like this, or we could go like this. That's 2 different kinds, but that's 2 ways to do it. Oh wait, I'm sorry, not like that. Forget the second one because that's a repeat, but we could go like this. Yep, like that. Okay. Next, we have like this, or we could go like this all the way across. Okay, so that's another 2. So kind of a lot to keep track of, but that's 8 in total. Answer choice D. Okay, we've got Andy and Bethany. Rectangular array of numbers, 40 rows and 75 columns. Andy adds the numbers in each row. The average of his 40 sums is A. Bethany adds the numbers in each column. The average of her 75 sums is B. Okay, we want to know the average of her. What is the average of A over B? All right, so there's 40 rows. That's what Andy's counting. So he's going to add up. His sum is going to be 40 times his average, right? That's the sum. Bethany adds the numbers in each column, so her average is going to be 75 times B, right? That's what the sum of all of her numbers is going to be. And we want to know the value of A over B. So A over B, will that just be 75 to 40, right? We basically flip the average, right? 40A to 75B. A over B then would be 40A to 75B. We can divide 40 on the 8 by both sides by 40, so then we get A is 75 over 40B. And then we divide both sides by B, so A over B is 75 to 40. Answer, and then we can simplify that, right? Both numbers are divisible by 5, so 75 divided by 5 is 15. 40 divided by 5 is 8. So the ratio is 15 to 8. Answer choice D. How many whole numbers between 1 and 1,000 do not contain the digit 1? All right. Well, we've got between 1 and 1,000. So it can't be 1 or 1,000. So that means it's going to be a 3-digit number, right? Because it's less than 1,000. And we want no digit 1, right? So that means our hundreds place can be any number 0, 2, 3, 4, 5, 6, all the way to 9, right? It just can't be a 1. So we get 0, 2, 3, 4, ... all the way to 9. So that's a total of 9 choices, right? 0 is 1, 2, 3, 4. Counting that all out makes 9. The same is true for the tens digit. It could be 0, 2, 3, 4, all the way to 9. And the same for the ones digit, all the way to 9. So there's 9 choices, times 9 choices times 9 choices. 9 times 9 times 9. 9 times 9 is 81. Times 9 is 729. Okay, now wait a second. I don't see that as an option. And that makes sense too. Because let's consider there's a chance that we counted out 0, 0, 0. Right? Because we let all of the digits be 0, that could be a possibility. So 0, 0, 0, that doesn't count as a number between 1 and 1,000, so we can't let it count as one of our possibilities. So we subtract 1 for that case that we counted. We get D, that's 728. All right. Okay, Mrs. Wonderful, love that last name, gave jelly beans to her class. Each boy as many jelly beans as there were boys in the class. Each girl got as many jelly beans as there were girls in the class. It's a little weird. She brought 400 jelly beans, and when she finished, she had 6 jelly beans left. There were 2 more boys than girls in her class. How many students were in her class? All right. So she brought 400 jelly beans, and she had 6 left. All right. So we found out that she had 394 jelly beans left over. And she had 2 more boys than girls in her class. So let's do some examples. Let's say there's 26 students, like in answer choice A. Then we would need things to add up to 26, right? So that'd be, remember, boys equals girls plus 2. So girls plus 2 plus the number of girls needs to equal 26. So in that case, we've got 12 girls, 14 boys. What if there's 28 students in the class? That's 13 girls, 15 boys. Continuing on, 30, 14 girls, 16 boys, 15 and 17, and lastly 16 and 18. So we want these squares to add up to 394, right? So girls, there's going to be G times G jelly beans for the girls plus B times B jelly beans for the boys. So we basically square the number of girls and add that to the square of the number of boys to figure out how many jelly beans that is. So 12 times 12, we got 144. And then 14 times 14, that's 196. Adding that together, that's 340 jelly beans. That's not enough, right? That's not our number. Okay, what about 13 girls and 15 boys? 13 times 13, that's 169. Plus 15 times 15, that's 225. That's a total of 394. So that's our number. 13 girls and 15 boys. Answer choice B. Okay. We have AB plus CA equals DA, and AB minus CA equals A. What digit does D represent? Well, if AB minus CA equals A, that means CA plus A is AB. Okay, so what does that mean? Well, to start, A plus A gives 2A. So that means B would have to be an even number, right? Because if A was 1, then we'd have 1 plus 1 is 2. A were 2, 2 plus 2 is 4. 3 plus 3 is 6. So no matter what A is, adding them together will make B an even number. So B is even, that's the starting point. Okay. We also have that A has to be 1 more than C. Right? A is 1 more. All right. So we see in the second equation, or in the first equation, that we have B plus A, and that equals A, right? So in that case, what number plus a different number will equal? So if we have A plus B and it equals A, that means B isn't changing A, right? It's keeping it the same. So if B isn't changing the value, that means B has to equal 0, right? B is 0. Okay. Now we have 0 for both of these. And that means CA plus A has to equal AB, or A0. So if A plus A gives you something that ends in 0, and A can't be 0 itself, that means A has to be 5, right? If A is 5, then A plus A will be 0, and we have something ending in A. So A equals 5. So now we have 50 plus C5 equals D5. And 50 minus C5 is 5. All right, so now we can solve for C, right? 50 minus something equals 5. 50 minus 45 is 5, right? That means C is 40, or C is 4, okay? That gives us enough to solve for things. Our first equation can be changed to A, B, 5, 0, plus CA, 4, 5, equals DA, which is 95. So D is 9, answer choice E. Okay? 1 cubic foot cube, a 1 cubic foot cube, love that, is cut into 4 pieces by 3 cuts parallel to the top face. The first cut is half a foot from the top face, the second cut is 1/3 of a foot below the first, and the third cut is 1/17 of a foot below the second cut. Interesting. From the top to the bottom of the pieces are labeled A, B, C, D. The pieces are then glued together end to end in the order CBAD to make a long solid as shown. What is the total surface area of this solid in square feet? Interesting. So, let's see. We know the top face, right? This is a 1 foot by 1 foot. So this top face is 1 foot. So the surface area of the top of all of these surfaces is 1, even though they all have different other parts. Right? They're all going to have a 1 there. The other part that they're going to have is their frontwards faces, this one. Okay, so we want to find the surface area. Well, we know that the top of everything, the tops, that's still a unit cube, right? Or a unit square, right? This is a 1 by 1 space, so all of those are 1 by 1. So that's going to add 4 to the surface area, right, for the top. So that's 4. And the same goes for the bottom. The bottom is also 4. Now, what about the front? Well, in total, they're all going to add up to 1, right? Because this, right? Because when they're stacked together, this plus this plus this plus this, they all have surface area 1 in total, right? They combine to make 1. So that's a 1. And the same is true for the back. This surface area plus this surface area plus this surface area plus this surface area, they all combine to make 1. Okay, last we have this view going this direction. Well, we can see that, let me draw this, or maybe not. This bit plus this bit here shaded in, plus this bit here shaded in, they all come together to form something that has height of A, right? That goes up to the height of A. We know A has height 1/2, right? So that combines to have height 1/2, right? So that's the surface area there is 1/2. And then from the other side, it's the same thing. That bit plus the face on that side, they're combining to make another 1/2, right? When you put them all together, you make 1/2. We don't need to find them all individually. We're lucky enough to be able to just do the 1/2 part. There's a 1/2. There's another 1/2. Adding that together, we get 4 plus 4 is 8, plus 1 makes 10, plus 2 1/2s, that makes 11. Answer choice E.